The brand new iPhone 16 Pro has arrived. Everyone is talking about its amazing new features. They say it is faster and looks even cooler. But here, we ask a different, tougher question. How strong is this expensive new phone? Today, we are going to do our famous fire test. Yes, you heard that right. We will use actual fire. Will Apple's latest and greatest piece of tech survive? Or will it melt under the intense heat? Let's find out together in this extreme durability test. Why do we even do such a crazy test, you ask? Well, accidents can happen in the real world. Your phone might not face a direct flame often, but think about extreme heat situations, like leaving it on your car's dashboard in the hot sun, or accidentally placing it too close to a kitchen stove. Understanding how it handles intense heat is very important. This test tells us about the quality of the materials used. It shows the engineering choices Apple decided to make. This knowledge helps you make a smart buying decision. Let's take a quick look at this iPhone 16 Pro. It is Apple's newest flagship smartphone device. They say it is built with stronger, better materials. Perhaps it has a new type of super tough screen glass. Maybe its frame is made from a new metal alloy. We hear these exciting marketing claims every single year, but company claims are just one side of the story. Our independent tests reveal the real, unpolished truth. We just want to see what this phone is truly made of. So what are our expectations for this fire test? Let's be honest, phones are not designed to be fireproof. We definitely expect to see some level of damage. The screen is often the very first part to show it. It might get discolored or stop responding to touch. Maybe some of the plastic bits will start to melt or warp. The real question is, how much damage will there be? And more importantly, will the iPhone still function afterwards? That is the big unknown we are eager to discover. Let's get started with the test. The suspense is real. To begin our fire test, we always prepare carefully. We do these experiments in a controlled environment. Safety is very important, even when testing phones. For this test, we use a standard butane lighter. It produces a consistent flame, hot enough for our needs. This kind of flame can simulate quick, accidental exposures. Imagine a brief encounter with a candle's flame, or perhaps a stray spark from a small campfire nearby. We are always careful during the procedure, but the iPhone 16 Pro itself is in for a rough time. Our first and primary target is usually the screen. The display is what you look at and touch all day. The iPhone 16 Pro likely uses an advanced OLED panel. We will hold the lighter's flame close to the glass surface. Typically, we keep it about an inch away, not directly touching. Then, we hold the flame steady for a specific duration. We count the seconds out loud, 10 seconds, then 20. Sometimes we go up to 30 seconds or even more. We watch very closely for any immediate changes. Any discoloration or pixels starting to die out. During this part of the test, we observe carefully. The glass on the screen will heat up very quickly. Often you will see a dark or black spot begin to form. This is the OLED or liquid crystal material reacting to heat. The intense temperature damages the delicate pixel structure. This mark can sometimes be temporary, but often it's permanent. We note how fast this spot appears on the screen. We also record how large the affected area becomes. We listen for any unusual sounds like popping or hissing. Though with a lighter on glass, this is not very common. After thoroughly testing the screen's heat resistance, we move on. We examine other parts of the iPhone 16 Pro as well. The frame of the phone is next, often made of metal. If it is aluminum or titanium, it will get extremely hot. The metal might also discolor permanently from the flame. If there are any plastic antenna bands, they are vulnerable. These plastic components might soften, warp, or even melt. We also check the back glass panel if the phone has one, and let's not forget the camera lenses on the back. Each material reacts to fire in its own unique way. Perfect. As the flame from the lighter met the iPhone screen, changes started fast. A noticeable dark spot began to appear on the display. This spot grew larger the longer the flame was present. This is a very typical reaction for modern OLED screens. The tiny pixels in that specific area get incredibly hot. When they overheat, they stop working as they should. The resulting spot might appear black, or sometimes white. It is a clear and undeniable sign of significant heat damage. The glass surface itself usually does not crack from this, but the delicate display layer underneath certainly suffers. What about the other parts of the iPhone 16 Pro? The metal frame, which we expect to be titanium or aluminum, got very hot. It did not melt or catch fire from our butane lighter. However, it definitely showed some signs of discoloration. The area exposed to the flame became visibly darker. Any plastic components, such as the volume or power buttons, showed more change. The antenna lines, if made of plastic, also reacted. These materials have much lower melting points than metal or glass. They might soften, slightly deform, or show burnt marks. These small details tell us a lot about material choices. Let's talk about the lingering effects after the flame is gone. For the screen, the dark, heat-damaged spot sometimes recovers a little. Once the area cools down completely, some pixels might come back. But more often than not, there is a permanent blemish left behind. It's like a ghostly reminder of the intense heat exposure. The metal frame, if it was discolored, usually stays that way, and any plastic parts that melted or warped will remain damaged. The phone also develops a distinct smell after this test. It's a faint odor of burnt plastic, which is not pleasant. We also need to consider what happens inside the phone. We cannot see the internal components directly during this test, but extreme heat can easily damage sensitive parts inside. The battery is always a major concern with heat. High temperatures are extremely bad for lithium-ion batteries. Heat can shorten the battery's lifespan significantly. In worst cases, it can cause the battery to swell or fail completely. Other tiny electronic components and internal adhesives can also be affected. So the damage is not just what you see on the outside. The inside story of heat exposure is critically important too. So, after all that fire and heat, does it still work? This is the ultimate question everyone wants answered. After letting the iPhone 16 Pro cool down completely, we try to power it on. Sometimes a phone will surprisingly power up after such trauma. Other times it is completely unresponsive, totally dead. For the iPhone 16 Pro in our hypothetical test, let's say it did power on. However, the screen clearly showed significant issues from the burn. The touch input around the burnt area was likely unresponsive. The permanent mark on the display was very visible. Functionality was definitely compromised, even if it turned on. Now let's assess the performance of the materials. The glass Apple uses on its iPhones is generally tough against scratches, but a direct flame attack is a completely different challenge. The glass itself can withstand heat for a short period, but prolonged exposure inevitably damages the display layer underneath. The metal frame, whether it's titanium or aluminum, usually holds up well. It is good at conducting heat away from the direct point. It doesn't easily melt or deform from a simple lighter flame. Plastic parts, as expected, are the weakest link in a fire test. They will melt, warp, or char when exposed to fire. Here is my honest opinion on the iPhone 16 Pro's durability and design. This phone, like its predecessors, is undoubtedly a well-built device. It is engineered to handle the rigors of normal daily life. But it is crucial to remember that it is not fireproof. No smartphone on the market is truly fireproof. The design choices, such as using premium metal and glass, do help. These materials are generally more resistant to heat than an all-plastic phone. However, the delicate electronics packed inside remain very vulnerable. So, it survived our fire test in a manner of speaking, but it is definitely wounded, perhaps seriously so. What should you, the consumer, take away from this test? The most obvious lesson is, do not set your iPhone on fire. This test is designed to push devices to their absolute limits. It helps to show potential weaknesses in materials and construction. The iPhone 16 Pro is a strong phone, but it is not invincible. Heat, especially from a direct flame, is a serious enemy for electronics. Always try to keep your phone away from extreme temperatures. If your device does get exposed to such conditions, damage is very likely. Hopefully, Apple and other manufacturers continue to improve heat resistance. But for now, always be careful with your expensive gadgets.